Yeah,
It will.
it will be given. When it will be calculated, it will be given to you.
So today I want to discuss a doubt with you about the continuity of these functions.
Okay, okay, we'll discuss. We'll discuss.
Good evening.
Okay. Good evening, everyone. So today is basically your last session of week 11.
Okay, sir. Okay.
So have you? I mean, those who are present now, have you attended the last live session for week 11? I mean, many topics I think have been discussed there, right?
Yes, sir.
Okay. So can someone just summarize what are we doing in week 11 basically? Then I will discuss accordingly. But let's start from your side. What have you learned from week 11 of this course? What are the topics we are discussing basically? Yeah. Anyone?
Sir, higher order partial derivatives and how to identify a
Hmm.
critical point to be a local maxima, minima, or a saddle point, and
Yeah.
Hessian
Right.
matrix, and whether the function is differentiable or not, and how the differentiability implies that the function is continuous.
Yeah, correct. So basically, these are the four topics of the four lectures. Yeah, but so to begin with, why we need higher order partial derivative? Any idea? Why we need that? And this is the first question. And another question is very basic. What is basically higher order partial derivative? What do you mean by that? Have you seen anything analogous in single variable?
Yes, sir.
Yeah. Where?
Sir, in similar to
I
in the
mean,
single variable,
how? Yeah.
the second order derivative,
Mm-hmm.
by second order derivative, we used to identify whether the critical point is the local maxima, minima, or it is the global maxima, minima. Mm,
Exactly, exactly. So basically to classify the critical points, right? That's where higher derivative is needed. And that was similarly when we have studied single variable calculus, it was like same. So we have calculated the second order derivative. Now here are more than one variable, so we need to find fxy and fyx for two variables, right? And so that is basically what we are doing here. Uh, okay, so before going to, I mean, before starting the discussion, do you have any doubts till this point? I mean, till week 10? Any doubts so that we can start from there? Anyone wants to ask some doubt? No doubt till that point, week 10. Okay, great. So we can start our discussion from here itself. Okay, so let me share my screen first.
Sir, I want to ask one basic doubt.
Yeah, go ahead.
Sir, while identifying a critical point, whether it is a local maxima, minima, or global maxima, minima, saddle point, and the differentiability, do we always have to check that
Mhm.
whether the function is continuous or not before that, before approaching all that? Because we need gradient. In all these critical points, identifying critical points and all that. First of all, we need the gradient. And do we always have to check whether the gradient is continuous or not?
Yeah, so uh, so first of all, I mean, to begin with, whether the gradient exists at all or not, that is the first question. Whether the gradient exists or not. Then you have to check whether gradient is continuous or not, because we are using fxy and fyx. Those may be equal or may not be equal, right? That depends on the continuity on fx and fy.
Yeah.
Correct? That is
Okay.
the statement of Clairaut theorem. Correct?
Yeah, sir. Similar to
But
this one.
when we are asking but when we are asking about existence of local minima or local maxima, I mean, you have to identify the points. That means it is already inherited in the question that the function is a nice function, basically. So all these things are continuous, all these exist. Okay, so we assume that, and that's why we are asking that question. But when we are working in a real life situation, so you came up with some function and you want to know the local maximum minima, then you have to go step by step. First, you have to check the continuity of the function, then the continuity of the first order derivatives. Then you can come to Hessian matrix. Before that, you cannot know
Yeah.
whether those Hessian matrices at all exist or not, right?
Okay. You mean to say that the
Have you understand
exam?
what
Yeah.
I have said?
Yes, sir.
Yeah.
You mean to say that while approaching the questions in the course or in the assignments, they are the nice functions. We don't need to calculate much. Whether we don't need to worry about whether they are
Yeah, we
continuous or
are
not.
we are dealing with the nice
But
function, exactly.
otherwise, first we have to check whether the first step is
Exactly.
to check on the gradient, and then second step is to check on each higher order derivative.
Exactly. Then you have to go step by step.
Yep.
Okay.
Yeah.
Okay. So I am using the slides just to I mean, point out what are the topics we are discussing. Then we'll go back to the writing sheet and write that. So I think you have seen this function before, right? Fxy equal to xy into x square minus y square by x square plus y square, when it is not at origin and otherwise it is 0. So I think you have seen this function. Now my question is, so can you write down this function? I hope you have pen and paper with you. So please write down this function. Then I will ask the question related to this. Okay. So let's get back here. So is at 0 0 this function fxy equals fyx, that is the question, right? So basically we are asking whether the Clairaut theorem, this function satisfy the Clairaut theorem or not. Okay, so what is fxy? Fxy is del x of this. So at first you take the first order derivative with respect to y, then again you take the derivative with respect to x, and if yx is del y of del f del x. So first you do it with respect to x, then with respect to y. So how can we approach this problem? So our function was like this.
So take a limit.
Hmm? Can you repeat? Your voice is breaking. Okay, so how can we find what is fxy 0 comma 0?
Sir, in the second step, I mean, fxy should be fx with respect to y. First, sir, we have to get the for fxy first the derivative with respect to x, and then its derivative with respect to y.
Sir, first we
So you are saying I have written it I mean,
Otherwise, yes.
wrongly, is it?
Yes, sir.
Okay, so basically it's a convention what depends on what we are doing with. So okay, anyway, basically I need these two, whether these two are equal or not. Okay, first with respect to y, then with respect to x, and then first with respect to x, then with respect to y. Okay, so how we can approach it? How we can approach it to
so first
answer
we
this question?
differentiate partial differentiate with respect to y and
Hmm.
with respect to x when function is not 0, 0.
Sir, first we
Yeah.
get the derivative with respect to x using the
Okay.
quotient rule.
So we applying a
Hmm.
u.
Okay. So if I want to find this one at 0 comma 0, right? So what is the definition for this? This is fy with respect to x, so h comma 0 minus fy 0 comma 0, right?
Yes, sir.
By
Upon
h.
h.
So we need to find what is fy 0 comma 0 and fy h comma 0. Do you know this thing?
Yes. Sir, fy is
Yeah. So,
x to the power 5 minus 4x cube y square.
okay. So fy xy. This one.
X to the power 5 minus 4x square y x cube y square x cube
Hmm.
y square minus xy
X cube y
power
square,
x cube y square minus
xy power 4.
x x into y to the power 4 y to the power 4. So I'm audible.
Okay. And below? Yeah,
Sir,
but I don't know. I am
x to
hearing
the
your voice
power.
breaking.
Sir, I'm audible.
Yeah, now we are audible. Yeah.
Upon x square plus y square का whole square.
Okay. Does everyone get this? Fy xy.
No, sir. Can you please elaborate it little bit?
Okay, so basically we have to differentiate this function. So when xy is not origin, we are differentiating with respect to y, right? So our function is this one, x cube y minus xy cube by x square plus y square, correct? So we have to differentiate with respect to y. So this is the quotient function. So what we'll get, this is x cube minus 3xy square into x square plus y square minus this remain as it is, and this is basically 2y by x square plus y square. This is whole square. This is what we need, and if you calculate it, it should be x bar 5 minus 3 x cube y square plus x cube y square minus 3 x y power 4, then minus 2 x cube y cube, sorry, y square, and plus 2 xy power 4, x square plus y square whole square. This is the function.
Okay, sir.
Okay, so
Yeah, yeah.
I think after calculating what we get, x bar 5 and yeah, so 3 to 5 minus 4 x cube y square and minus xy power 4 by x square plus y square whole square. Right? So this is what we get. Fy xy. Right?
Okay, sir.
So we
Yes.
need two things. One is fy h comma 0, another is fy 0 comma 0. These two things we need. Correct? So this is where xy both are non-zero, not origin. So we can just substitute h here. So h power 5, all this term will be 0, and this is, I think, h power 4. So this is h.
H.
Correct? And what is fy 0 comma 0? Fy at origin?
0.
Is it? Fy 0 comma 0? This is 0h minus 0 by h, right? This is by definition.
Yes, sir.
So f of 0 comma 0 is 0, because that's what we have defined here. F of 0 comma 0 is 0, and 0 comma h is also 0, right? If you substitute 0 comma h, so it falls in under this condition. So 0 comma h, it will be also 0. So this is eventually 0. So f of del x of fy at 0 comma 0, this is limit h tending to 0, fy h comma 0 minus f of fy 0 comma 0 by h by definition. So this is what we get, h minus 0 by h. So it is 1. Correct? Till this one, do you have any doubt? Anyone?
Sorry, sir, I didn't understand the last two
Anyone
lines.
have any doubt till this point?
Hello, sir.
So last,
Hello.
yeah.
Sir,
So
am I
this is
audible?
what we are calculating. This is basic. Yeah, you are audible. Can you hear my voice?
Yes, sir. What I'm asking is, I understood till where we found fy at 0, 0, 0, comma 0. I didn't understand the last part, this last two lines.
So this is basically, we have to calculate this thing, right? This is what we need to calculate. One is fxy as 0 comma 0, another is fyx at 0 comma 0, right? These two we have to
Yes.
calculate.
Yes.
Correct?
We're starting with the
So for this, so suppose the first one.
fyx. We're starting with fyx.
So first with respect to y, then with respect to x. That is what we are calculating. Okay?
Yes. Fyx, right?
This is fyx. So I think I have written here wrongly. So This is your fyx, and this is your fxy. Right? This is the convention Cyrus solution. So yeah. So for that we need fy h comma 0 minus fy 0 comma 0, because we are differentiating fy with respect to x, so we have to take the increment in part of x. That's why we have chosen h here.
Yes.
And
Yes.
so we have calculated both of these two, fy h comma 0 and fy 0 comma 0. We are just substituting it here to find this. So
Okay.
this is your
Okay.
fyx,
Okay. Okay,
right?
I got it. Yeah, I
Yeah.
didn't see the substitution part of it. Okay, fine.
Okay. Now, can someone tell me what is this one? Can you calculate it by your own and tell me what is this one? So same thing we have to do, but now we are doing it differentiating fx with respect to y. So this is fx 0 comma h minus fx 0 comma 0 by h, correct? So we need to find two things. One is fx 0 comma h and fx 0 comma 0. These two we need to find. So what is fx x comma y? Anyone have already calculated?
X bar 4y minus 4x squared y cube minus y bar 5 by x squared plus y squared the whole square.
Great. Everyone got this? So this is what is fx 0 comma h.
It will be
fx
minus
0 comma h.
h.
It will be. So this, wherever there is x, there will be 0. So it is minus h bar 5 by h bar 4. This is minus h. And fx 0 comma 0, again if we calculate it by the definition, it will be 0. So fxy 0 comma 0, that will be limit h tending to 0, fx 0 comma h minus fx 0 comma 0 by h. So we are eventually ending with minus h by h. So this is minus 1, correct? So these two are different, as we can see. This is minus 1, which is not equal to 1, and 1 is basically this. That we have seen. So this function we have started with, that does not satisfy Clairaut's theorem, right? Is it clear to everyone that this function does not satisfy Clairaut's theorem?
Yes, sir.
Right? Okay. So if we go back here, so this function does not satisfy Clairaut's theorem. Now, where it go wrong? Where it went wrong, basically. So Clairaut's theorem is saying we have a scalar valued function defined on the domain, so containing some point. Now, if both fxi, fxj, so here it is fxy and fyx are defined and continuous in an open ball containing the point this, then these two are equal. So what it is saying, for two
This means
variables,
that
let's
this
simplify it.
function is not continuous. Then only it can fail.
No, so what Clairaut's theorem is saying, Clairaut's theorem does not demand the continuity of function f. It's saying that suppose we have function like this, and at the point a comma b you are trying to find fxy and fyx. Now if both of these fxy and fyx both are defined on a comma b, this is the first condition. The second condition is both are continuous at a comma b. These two functions need to be continuous. That is what Clairaut's theorem is saying. as you can see here. Okay, these two, the double derivative, so higher order partial derivative, are defined and continuous in an open world containing the point AB. So continuous as AB means what? So there is a point on your xy plane. So this is your point AB. So if you take some open wall around it, so the function will be continuous around it. Okay. So that means if you check the continuity at a comma b, that will be enough. Okay. So here fxy and fyx, so we are checking it around the point 0 comma 0, right, for our function which we have already checked. So both this fxy at 0 comma 0 and fyx 0 comma 0, both are defined. That part is okay because we have found the value of both of this function, right? But does those function continuous at 0 comma 0,
No.
fyx and fyx?
No, sir, no.
No.
Why? Why?
Both the values are different.
Hmm?
Values are
The
different.
limits are different, no?
But limits are different for both this function. But
Limit
my
exists.
question is,
If limit is exist means the function is continuous.
but we need to know whether this function is continuous or not. Fxy is fxy continuous?
Sir, intuition is that this function is not continuous. Because if it had been continuous, then the Clairaut's theorem had been satisfied.
Exactly. So you are taking it in opposite direction, but I am saying, suppose you don't know Clairaut's theorem. I am just asking you this question: is fxy continuous at 0 comma 0? Then what you have to do? Then you have to find your function fxy, right? So we have already find what fx is. Then again we have to find what, differentiating with respect to y. Then we'll get some fy, and then we have to check whether that function is continuous or not, right? So if somewhere we need to know that whether this fxy is continuous or not, so it is a easier way to check, first to check that whether this both fxy and fyx, they are equal or not, right? Because if it is continuous, then they must be equal. Now if they are not equal, then also they are, then you directly can conclude that this function is not continuous at 0 comma 0, correct?
Sir, I have a confusion here.
Hmm.
Every time we check on 0 comma 0,
No,
all the question in all the question.
No, that does not necessarily 0 comma 0. We can check it for any other point. That depends on the question. Okay? That
Sir,
depends on the
every
question.
time question, this type of question, always say this function is x, y at
Because
non-zero.
if you can check it for 0 comma 0 for some type of function, then you can do it for any other points, because you have to just shift the point to 0 comma 0. Right? So it is enough to check for 0 comma 0. For practicing for 0 comma 0. That's my point. Okay? That does not necessarily it has to be for 0 comma 0.
And
Okay?
one thing more, sir, while checking for 0 comma 0, we have always to go by the definition, right?
When you are checking the existence of something, then you have to go by the definition.
That is f of a plus h minus f of a, that sort of thing.
Yeah, right. Okay, so the point 0 comma 0 is nothing special. Okay, so we are checking for all this type of function and do it for 0 comma 0, but 0 comma 0 is nothing special. We can ask some other function where it is not continuous at some other point 1 comma 2 or 3 comma 4. Okay,
You ask the
the
question.
process will be same, but 0 comma 0, it is easier to check, it is easy to calculate. That's why we are formulating this type of questions. Okay, is it clear?
Yes.
Okay.
Sir, I have a very basic question. I don't know if it's even. We are saying that fxy and fyx at 0, 0 are both defined, and are both defined. They are defined in the sense that we've just calculated
Yeah,
their
we calculated the
derivative,
value of the function at that point.
the derivative. That
Uh,
okay.
these two,
This
not the derivative.
minus
This,
1 and plus 1.
yeah, exactly. So
So
at
that's
0,
why we're
0,
saying
they are
it's
defined.
okay. And
Yeah.
then how would we check the continuity?
So for checking the continuity is the difficult part basically. So you know what is fxy x comma y, right? Fx x comma y, this one. Now you have to find what is f y x
Zero.
x comma y. Then you have to differentiate it again with respect to y, right? Then at 0 comma 0, what is the definition, right? Then you have to check the continuity for the function.
Sir, may I ask one thing? Sir, in this line just visible fx of x comma y is equal to this. Sir, we can reach this if directly differentiate this function using the quotient rule. Sir, why are we then going by the limit h approaches 0, f of x 0 comma h?
Because we are doing it for any arbitrary point. Other than 0, at any arbitrary point, the definition of the function is fixed, right?
Yeah.
So this definition is true for any point other than 0, right? So if you choose any arbitrary point on xy plane, suppose this is your a comma b, and you take a neighborhood open ball around that point a comma b, everywhere the function is defined by this equation. I mean this property xy into x square minus y square by x square plus y square, right? So here we can apply the quotient rule directly. We don't need to go by the definition. The problem arises only when we are doing it around 0, because at 0 there is a different definition, right? So when we are calculating it around 0, then we need the definition, because they are at, I mean here and at 0, at these 2 points the definition of the function are different. Then we need the definition of partial derivative. Otherwise we don't need.
Okay, sir. This means that when the definition is piecewise, then we have to check
Exactly.
at the discontinuous points. For each point, we have to go by the definition.
Exactly. That is what we have done in single variable also, right?
Yes, yes.
Yes.
Because even this here, there are two definitions of the function. We used to get even 3 definitions or 4 definitions.
Yeah. Correct. So what I am saying, just to conclude this discussion, then I will again take a question. So if I say that in this equation, in this problem, we have seen that these two are not equal, right? So it concludes that either fxy or fyx or both are not continuous at 0, 0, but we don't know which one. So if we want to know in particular is this one continuous, then we have to go by the definition of the function again. But when we see by Clairaut's theorem, I mean when we see that these two are equal, then by Clairaut's theorem we can conclude that either one of them is not continuous. That's for sure. Because if both of them are continuous, then these two must be equal. This is basically the negation of Clairaut's theorem. Okay, so that is what I intended to make here. Yeah. Any other doubt?
In a way, this is the converse of the Clairaut's.
Exactly. This is the
theorem.
negation of Clairaut's theorem. Okay. Okay. So yeah. So just now someone has asked the question about piecewise function. So suppose what should I say? This mod x. So in single variable, when we are discussing about differentiability of this function, okay. So you know that this function can be written as x if x is greater than equal to 0 and minus x if x is strictly less than 0. So when we are talking about suppose at 1, at x equal to 1, what is the derivative of the function? What is f dash 1? So you don't need the definition basically. I mean, by going the definition, you will get to the same thing. But at 1 means what? 1 thing here. So around this neighborhood, the function definition is basically x, if x equal to x. There is no other definition. So you just take the derivative of x and that will be your uh, derivative at the point 1, right? This is directly 1. But when I am asking at x equal to 0, right? Then we have to go by the definition, because if we take 0 is here, so around this neighborhood, at this side this is x, at this side this is minus x.
Yeah, we can approach it
So
from
both
either
side,
positive and negative side.
exactly. That's why we need by definition.
Yeah,
We
it's
need to go by
neighborhood
definition.
positive side and negative side as well.
Exactly.
Okay.
So do you get the point? Why, where we need to go by definition and why we just can write using calculation, right?
Yes, sir.
Yeah. Another thing, I mean, someone was asking that why 0 is important. I mean, 0 is not important at all. So if I write it this, right? So if you know how to calculate it for mod x, then you know, I mean, at x equal to 1, whether it is differentiable or not. The same type of approach you will take, right? So here the function will look like this. So at x equal to 1, there will be a breakpoint. Right?
Now the problem
The
lies at
sharpness will come. So if you know where to check for x equal to 0, then you know this shifting type of problem also. So that's why, I mean, nothing special with 0, but it is easier to calculate for 0. That's why we create this type of problem. Okay?
Sir, I have a question. The fact that fxy was not equal to fyx, how does that affect us in terms of maybe critical points and finding local minima and local maxima?
Okay. So when we are discussing, so let me come to the next thing, critical point. So till this point it is clear. I mean, what we have done here, then I will go to critical point.
yes.
Okay. So fine. So as you have seen, for critical point, the Hessian matrix come in the picture, right? And this is the general form of Hessian matrix for n variable. Now, suppose for two variable, if we want to write the Hessian matrix, how the matrix will look like?
So first we have got the gradient. In the first row, take the first component of the gradient and differentiate it with respect to x, that is element 1 1, and then differentiate the element first component of gradient with respect to y, that is the element 1 2. Similarly for
Similarly for the second row. Yeah, correct. So the Hessian matrix will look like this: fxx, fxy, fyx, fyy. Now, when a function satisfies the condition of Clairaut's theorem, that means fxy and fyx both defined and continuous, that means they are equal. So these two are equal, right? In that case. But just now the example we have calculated for this, these two are not equal. So only it will affect the Hessian matrix, because when they are equal, this is a symmetric matrix, right?
Yes, sir.
Otherwise, it may not be. Right? So that is the only point which affect the critical points. No other. I mean, no other
So we
property
can
will be affected.
so we can proceed as we proceeded. Although it's not a symmetric matrix, we can go with those conditions that we have
Yeah, yeah,
to find
yeah, definitely.
local minima
Yeah,
and local maxima.
yeah, definitely. We can proceed like that. Okay. Okay. So let's see. So the definition of Hessian matrix is clear, I think. There is nothing very much fancy here. So just solve this question. What is the determinant of the Hessian matrix of this function? So fxy is x square plus 3xy plus 7y square. So let me write. I have written it correctly. Yeah. Now what is your this? So you need to calculate fxx, fxy, fyx, and fyy. So what is fx?
19, sir?
Yeah. Yeah, probably it is 19. So fx is 2x plus 3y. Fxx is 2. What is fy? Fy is 3x plus 14y, right? And fyy is 40.
40.
What is fxy?
3.
3. What is fyx? That
3.
is also 3. So these two are equal here. So, and if we write this,
2,
it's 2,
3.
3, 3, 40.
Okay.
So this is a symmetric matrix, as you can see. What is supposed to be 28 minus 9, that is 19. The determinant is 19. Okay.
Sir, I want to ask a question here. Sir, just by looking, we have calculated the higher order derivatives of this. Suppose this function is not continuous and we approach this way, then we are going to get then the matrix would not be symmetric, sir.
Then the matrix would not be symmetric. Then you have to apply, where the function is not continuous. If you try to find the Hessian matrix at that point, then you have to go by the definition. You have to check whether at each point the higher order derivative exists or not. Then you have to check all these things.
Sir, can you
In the
please
definition.
take an example if possible?
Yeah, I can take, but that will be just calculative, and those type of things may not appear in the question because that will be very calculative for these course. Okay. So if you take this question which I have just done.
Okay, sir. I ask my question another way.
Yeah.
Sir, suppose any function is given to me and I calculate the first order and second order derivatives with that. I do not get a symmetric matrix, then I can conclude that the function is not continuous.
That will come, before calculating Hessian matrix, that will be clear to you, because you have to go by the definition for that point. Now by giving this function, if I ask you to calculate the Hessian,
yeah,
right, then you cannot directly calculate fxy without using the definition as I have done here, right? Because at 0, 0.
Okay, then we have to first go by the definition and check.
Then you have to go by the definition at each step. So you have to calculate fxx 0, 0 using definition, fyy 0, 0 using definition, and as these two we have already calculated. Then you write the Hessian matrix, then you can calculate the determinant. The process will be same, but here you need the definition.
Okay.
Because the function is not defined, nicely around 0, right? There is a breakpoint at the origin.
Sir, after what the current question that we're doing, would it be possible for you to do this particular question that we had started with earlier? Could we solve this? Could we solve this also question that we have just found? This one. Could we solve it for its critical points and all that? Once we are done with the question we have already started.
For this point, is it?
Yeah, for this particular function, yeah.
Yeah, you can do it. There is no issue with that. But I think, what is fx? What is fx we have calculated? Fx and fy, as you can see. So this is your fy, right? So it should be equated to 0 for critical point. And again, for fx, you got something that should be equated to 0 for finding the critical point. Now solving.
And how do we find? How do we find critical points for such questions?
So solving these two are not easy. That's the point. The finding critical point is not easy at all for this function.
Yes.
Right? You have to use some programming or some other graphs of this function to solve the question. right? You cannot solve it by hand, probably. Probably, I am not sure. Probably you
We
cannot
can't
solve
say
it by
that they
hand.
don't have critical points.
You can say because 0, 0 is already a critical point, right?
Okay.
So can someone tell me what is fx and fy we got in that function? Then I can write it. What was fx?
For what, sir?
What was fx for the function we have given earlier? Huh,
Fx
this function. What was fx?
minus y to the power 4.
Fx minus y to the power 4. Is it?
Yes, sir, this one. Y to the power 5, sorry.
Huh, minus y to the power 5, right?
Hmm.
Okay. Yeah, minus y to the power 5.
Plus x to the power 4 into y
Hmm.
plus 4x square y cube
Hmm.
by x
By
square
this.
plus y square whole x.
Now, what was fx1? If y of x1?
Y is x to the power 5 minus 4x cube y square minus xy to the power 4 upon x square y square.
Yeah. Now, if we equate both of these to 0, right? That's where the critical points lies. All those xy's will satisfy this point. So basically, we are getting uh, these two equations. Okay.
Yes.
Okay. So for the first one, if we take y common, I will get this. And for the second one, if I take x common, I will get this.
X is
Right?
equal to 0 and y is equal to
So one solution is obviously x y equal to 0 comma 0. And that was also
this
clear because the function is not defined as 0 at that point, so differentiability will be affected. So that will be a critical point. And we can assure it from this equation, right? So for 0 comma 0, that is a critical point. Now, if I want to know whether this 0 comma 0, I mean, what should I say? Is it a local maxima or local minima saddle point, right? That is the next question you will ask. So for that, we need to find fxx x 0 comma 0 and also the Hessian matrix of the function at 0 comma 0, right? These two we have to calculate. Now, to calculate fx x 0 comma 0, you have to go by the definition, right? Because at 0 comma 0, the function is defined separately. So, limit h tending to 0, fx h comma 0 minus this, correct?
yes.
Yeah. Now, you know what is fx h comma 0, right? We have already calculated it somewhere, no?
It's going to
So,
be 0.
it's going to be 0, right? This is your fx, so h comma 0. This is going to be 0. So this is eventually it is 0, right?
Yes.
And so now you know how to calculate fy 0 comma 0 also. That is also 0, I think,
So
right?
if we got 0 comma 0, 0 0 matrix, 0 matrix. If we,
No, fxy 0 comma 0 is not 0, no. It is 1, I think, or minus 1. What will
yes,
happen?
sir, 1
So
1.
determinant will not be 0. Determinant will be something else.
But sir, in this Hessian matrix, fxy is not equal to f by x. So
So, I mean, that is the matrix.
so
You
it
can calculate
should
the
be
determinant,
equal
no?
now. So it should be equal now. So then we find this is a symmetric matrix.
So I am saying when the function satisfies the Clairaut theorem, conditional Clairaut theorem, then at that point the Hessian matrix is symmetric. Otherwise, it may not be symmetric. And this is one example.
Sorry,
That's what you have asked, no?
sir, could you repeat that again? You're saying since
So I am
the
saying if fxy and fyx are not equal at some point, then the Hessian matrix is not symmetric, right?
yes, yes.
Yeah, that is what only I am saying. I am not saying anything else. Okay.
Yeah.
But you can calculate the determinant of the matrix, right? You can find a Hessian matrix and you can calculate the determinant, correct?
It will be -1.
I mean, whatever that is, it is -1.
No,
So,
it's
sir,
+1. Sorry, it's
Plus one,
positive.
plus one. Yeah.
+1.
Yeah. So that's what the case is. I mean, there is nothing special going on, but you have to do it separately. That is my point. Maybe a little bit more calculative, but you can do it like that.
Then in this particular case, it's +1, but fxx is 0.
Zero.
How?
So
What
maybe
do we
in
decide on that? What do we conclude on that?
so what was the condition for that? This one, right?
Yeah, it's either greater than 0 or less than 0 fxx.
Hmm.
so the
So
test is
here,
What will we do now here? The determinant is positive, but fxx is neither greater than 0 nor less than 0.
so basically by using this condition, we cannot conclude it is local maximum minimum, right?
Yeah, and we can't even
We
conclude
cannot
it's a saddle point also.
nothing can be concluded by using this test
Yes.
for this function. Yeah, I mean there is nothing we can do here. I mean we cannot
Okay.
conclude. That's it. That is enough for
Okay.
this function. We cannot.
Divya, it is very well explained in the 4th lecture.
Yeah, there can be some cases like this. Okay.
Okay.
Sir, suppose the function is of the form p by q and it is not piecewise. Suppose the function is x square minus y square upon x square plus y square. Then how should we?
1 minute. Let me conclude. So for this function, why this test does not give us anything? Can anyone point out? Why this test does not give us anything? I mean, why we get fxx at 0,00, which does not fall in any of this condition? What is the hypothesis for this test, this Hessian test?
The hypothesis is that the function should be defined and it should be continuous.
Not the function.
partial derivative.
Yeah,
Is
partial
second
derivative.
order partial derivative are continuous
Second order
around the
partial.
open wall a comma b, right?
So all the first and second order partial derivative, both.
All the first and second order, right? So
Yes,
here,
sir.
are all the second order derivative continuous? In this example, what we are doing at that point, this one. For this one,
Yes, sir. First order continue.
just now we have said that fxy 0,0 is not same as fyx 0,0, right?
Yes, sir.
Then by the negation of Clairaut's theorem, what I have concluded that either one of them or both are not continuous around 0,0, right? So this is second order derivative. So there is at least one second order derivative which is not continuous, right?
Yes.
Is it
So
clear?
if Clairaut's theorem is not satisfied, and therefore one of them is not
Then we
continuous, then we
cannot-
can't even
yeah.
use the Hessian matrix.
I mean, we can use, but we cannot get any conclusion from there. That's my
Yes.
point. Okay.
Okay. Yeah.
So Hessian matrix will only give me a conclusion when the Clairaut's theorem is already satisfied, right? Is it clear?
Yes, sir.
Okay.
Sir, in this question, the definition was.
That's why we came across all those examples where the Hessian matrix is symmetry. Because Clairaut's theorem is already satisfied. Otherwise, there is no point of doing this Hessian test. Okay.
Sir,
Clear, no?
here the definition was piecewise. Suppose the function is given like x square minus y square upon x square plus y square. It is of the form p by q, and 0, 0 seems to be a problematic point. Then we have to approach by the
then we need some definition for 0, comma 0. Otherwise, the function, 0 is not in the domain of the function.
Yeah, 0 is not in the domain. Then what should we do then, sir?
If 0 is not in the domain, then we should not be concerned about 0, comma 0. Whether the function is continuous at 0, comma 0, that is not also in our concern, right? Because we will only focus on those points which are in the domain.
Okay.
Correct?
Right. Yes.
If it is not in the domain, then why we are concerned about the continuity at that point? Right?
Right. Yeah, got it, sir.
Okay. So let's summarize this. I think this got a little bit intense at this point. So first of all, there is one thing which is called Clairaut's theorem, which says that if, so let me go back to the slides here. So this function, if both this partial derivative, higher order partial derivative, are defined and continuous in the open world containing this, right? So if for two variable, if fxy and fyx both defined and continuous, then they are equal. Continuous at suppose a comma b, then they are equal. Okay, so if they are equal, along with this plus the second condition, if these are also continuous, are continuous at a comma b, then we can get some conclusion using Hessian test. Okay. Otherwise, there is no point in applying the Hessian test. Okay. This is one thing. Third thing is, when we can apply Hessian test, the Hessian matrix must be symmetric. As the function must satisfy the Clairaut's theorem. Okay. So this is basically the gist of the problem. Is it clear? Is it clear to everyone? Or you have a doubt, you can ask. We can discuss.
So when we
Yeah.
find del xy and del yf, if the both are equal, so then we no need to any Clairaut theorem going in at all. We directly use the Hessian matrix.
DLF?
Double second partial derivative, fxy and fy.
So if we can find fxy and fyx at the point and they are equal, then we can directly use, but there may be some cases where fxs and fyy also may not be continuous, right? So it's better to find all the four higher order derivatives. Okay.
So can you show me third point? Thank you, sir.
Okay. So let's go to this. So now we can find, I think, this Hessian matrix also for this function. For three variable, what is the Hessian? How does the Hessian matrix look like? So we have function 3x square plus xz plus 2yz minus z square. So let's write it. Xz plus 2yz. Minus z square. Okay, so now how the Hessian matrix will look like? Yeah.
Del
Then what should be here?
XY,
Then
XZ,
yeah.
Ix,
Y,
Yy,
Y,
Yz,
Z,
Zx, Zy, Zc.
Z, Z.
Right. Now if all the partial derivative are continuous, so the Clairaut's theorem will be satisfied. That means these two will be equal. This and this will be equal, and these two will be equal, right?
Yes.
So basically, again, as we have seen, the Hessian matrix will be symmetric. Correct? So at which one do we need to find it? Let's see. At any xyz, right? So what is that? What is your fx,
6x plus 1.
fy, and fz? What is fxx,
6.
fxy,
X, X. 0, sir.
0, fxz,
1.
1. Okay, so if we write the matrix, what it will look like? 6, 0, 1. So fyx is also 0. What is fyy?
0.
0. fyz, 2.
2.
Zx, now we know xz, so zx is also 1. Yz, this is also 2. Zz is minus 2. Right? So this is the matrix we got. Okay, so this is our Hessian matrix for any xyz. It does not depend on the point. Right? So we can calculate the determinant also. So hopefully now we will know how to write the Hessian matrix for any multivariable function. Yeah. So why we need Hessian matrix? For test of the critical point. So if the second order derivative with respect to x is greater than 0 and the Hessian is also greater than 0, then it is local minima. Now if Hessian is greater than 0, the determinant of Hessian, and second order derivative has less than 0, it is local maxima. So these are the condition you need. And if the determinant of Hessian matrix is less than 0, then it is a saddle point. But even in this situation, if all the partial derivatives are continuous, all these conditions are satisfied, even in this situation, this test may be inconclusive if the determinant of the Hessian matrix is 0. In that case, the test may be inconclusive. So you remember for single variable, there was also a case where the test was inconclusive, right? When the double derivative is basically 0. So it is the same type of situation we can see here. When the determinant of the Hessian matrix is 0, then this test does not conclude anything. Okay. So I think this is also have, we have discussed in the last live session. So let's solve this problem. For what value of k, the Hessian test inconclusive for the function, this function. So when the test is inconclusive, the test is inconclusive only when the determinant of the Hessian matrix is 0, right? So x cube plus kxy plus y cube. Right. So let me write. So if x is 3x square plus ky, and if y is kx plus 3y square. Right. So what is fxx? It's 6x
6
fxy k, right? And fyy,
xy
6y, correct. So Hessian matrix at 0 comma 0 we need at this point. So this is 0 k k 0. So when the test is inconclusive, when the determinant of this matrix is 0. So what is the determinant of this matrix? Minus k square, right? And when it is 0, the value is
is
0.
0.
So when k is 0, then for this function, the Hessian test is inconclusive. Is it clear?
Yes.
So I think this is the easy problem.
You have given the point 0, comma 0, na?
Yeah, at 0 comma 0.
Okay.
Okay, that's why we can put the values. Yeah. Okay. Yeah. So this is another type of question. I think this is it's in your activity. So m denotes the maximum value of the function. So function is given like this as an integrated function over all possible values of a and b. Then find the value of 3n. So how we will approach this problem?
Should integrate first.
Correct. So 3 minus 2x minus x square. So f of ab is a to b square. This is the function, I think. So if we integrate it, what we will get? 3x minus x
X
square
square.
minus x cubed by 3, right? A
Yes.
to b. So it is 3b minus a, b minus a whole square, b minus a whole cubed by 3. So this is your function f of ab, right? Now we have to find what are the critical points and all this. So what is, now here are two variables a and b. So first with respect to a, what it should be? Right? Okay, so this is your FA of AB. I mean, if we differentiate with respect to A, we will get this. Is it clear to everyone?
Yes, sir.
Do everyone get till this point?
Yes, sir. Yes.
Yeah. Now, what is FB? Same thing we'll do.
It's the same.
But sign will be different.
Ah, yes, sir.
Okay. So, what are the critical points? We need to equate it both this to 0. FA of AB is 0 and FB of AB is 0. And all those ones will satisfy these two equations simultaneously. That will be our answer. Right? So, basically, when we equate it 0, both of them are same equation. Right? So, B minus A whole square plus 2B minus A minus 3, this is 0. Okay. So, what are the solution for this?
-3 and 1.
For B minus A, is it? So, if we write it like this, -3 and 1 mean what? What are the solution for, I mean, B minus A is 3 and 1, right? That is what you are saying.
Yes, sir.
Yeah. So this is basically like this 3B minus A. So minus 3 minus A minus 3. So I can write it like this. And I can take B minus A common. So B minus A minus 1 plus 3B minus A minus 1. So B minus A minus 1 and B minus A plus 3. Yes. So 2 things. And B minus A plus 3 is 0. So basically we have these two relations. B minus A is 1 and B minus A is minus 3. These two relations we have. Right? And we need to find the maximum value of this function, right? So what else we have to do now? To find the second order derivative, right? So for which point this will be maximum, this will be minimum, that we need to calculate, correct? Are you with me?
Yes.
Yes, sir. Yes. Yes.
Yeah, so what is the second order derivative of this function? What is FAA?
So minus 2A plus
Yeah.
2B minus A minus 2B minus A.
So minus 2. So from here we get minus 2 and here plus, sorry, minus 2B minus A. Right? What is FAB? FAB is 2 plus 2B minus A. And FBA will be also same.
So FAB 2 plus
2B minus A, no?
minus 2
2 here and 2B minus A. Right?
minus 2 minus to b minus a.
Why minus 2? If AB with respect
Sir,
to B, we have to do.
b respect.
So it is plus, no?
सर नीचे वाला देखिए सर एफ बी तो रिस्पेक्ट टू ए करेंगे
Then with respect to that, then it will be plus, no?
ओ सॉरी
Yeah. So now what is FBB? FBB is minus 2 B minus A, right? This one, correct? So there are two options for when B minus A is 1 and B minus A is minus 3. These two are the options. This is minus 3. So when B minus A is 1, what are these values? This is 0, right? Then this is 4. This is 4. And this is again 0, right? No, this is 1 minus 4.
-4
And when it is minus 3, what are the values?
-8 -4 4
Right? These are the things we are getting, right? Now, what are the conditions for maxima? So let's go back here. This
Determinant should be greater than 0 and the first f of x should be less than 0.
should be less than 0. So if x is less than 0 is coming for which thing? The next, this one, right?
b minus a
And determinant is, let's calculate the determinant, whether it is satisfying or not. So this is minus 32 and 16 minus 16. No? So for Hessian, this is,
Inconclusive.
this should be greater than 0. No?
Uh,
Have we, have we done a mistake here?
I don't know.
Have we done any mistake here at any point? Can you check once whether there is any point we have missed?
And I had done this by opening all the brackets. You did it with b minus a. That I found that very hard and expanded the whole thing.
So when you expanded the whole thing, it came correctly, right?
I think so. Yes, it came. I got the values of a and b.
Okay. So maybe I have made some mistake somewhere. Very good. So you expanded it from here itself, right? FAB.
Yeah, f of b. Yeah.
Okay. What are the values of AB you have got?
I got B is either -3 or B is 3.
Okay, and A?
No, sorry, 1. B is -3 or 1. And then accordingly, A is either -3 or 1. So I got 4 points.
That should be like that, but I don't know why it came like this. Okay.
Sir, here FFA is B minus A is equal to -3. Your value is 6 minus 2 is 4.
Where?
You did it plus 2 minus 1. Where I am it wrong? Sir, F A is it plus 3, B minus A square, 3 minus A. So it should be, sir, minus 2A B minus A, FAA.
FAA.
Hmm.
So FAA is -2
B minus A.
and -2B minus A. And it should be minus, you are saying, right?
Yes, sir. So if we put B minus A is equal to -3, so it should be 4.
So it is not the case. And when you put 1, then it is -4, is it?
Yes, sir.
-4. Okay. So this may be the possible case. And this is -4, and this is 4. So 16. No, I have done some mistake. This is again becoming 0. Somewhere I have done some mistake here. Okay, so let me check later what I have done here. So basically, you got the idea how to solve it, right? More or less, you have to find the value of the function, and then you have to do accordingly. Find partial derivative and find the second order partial derivative, and calculate the Hessian. Okay, so I will see where I have done the mistake later.
While
Just
derivation
right
b
now.
minus a square,
Yeah.
derivation of b minus a square with respect to a and with respect to b, is this,
Mm-hmm.
is it correct? Means it will expand to a square minus 2ab minus b square, na? So
Yeah. So it will be
so the
right.
derivation with respect to a will it be correct 2 bracket b minus a?
It is correct, no?
Okay, okay,
Because it is b square minus 2ab plus a square, right? This one. So if we take derivative with respect to a, this will be 0. This will be plus 2b, which I have written. This is minus 2a. This is minus 2a. So this will be same, right?
okay.
Yeah, I mean, this should be correct. I don't know where it is going wrong. Okay, I will check later and I will see where it is going.
Sir, can I ask one basic doubt?
Yeah.
So
Go ahead.
how did we replace x with b minus a?
So it is integration, right? Oh, sorry. Right. Sorry. This is oh, this is 3b minus b square minus b cubed by 3 minus 3a, right? A square a cubed by 3. This is what we should get, right? Correct?
Yes,
Yes, sir.
sir.
Yeah. Sorry. Little sorry. This is your FAB. Now you have to do the calculations. Yeah. I just put b minus a all over there. Yeah. So what is your FAB? This is minus 3 plus 2a
2a plus a squared.
plus a square. And what is your FBAB?
3 minus 2b minus b squared.
Now you equate both of these to 0. What do you get? As you have already said it. So A is what? Minus 3 and 1, right?
Yes.
Okay. And similarly, B is what is
Minus
B?
3 and 1.
Minus 3 and 1, same thing. Okay. And what is FAA? FA is 2 plus 2A. FAB is 0.
0
FBA is 0. And FBB is,
minus 2 minus 2b.
yeah, right. Minus 2 minus 2B. Yeah, correct. Now 4 points are there. Minus 3 comma minus 3, 1 comma minus 3, minus 3 comma 1, and 1 comma 1. All these 4 points are there. For these 4 points you have to check the conditions, right? So let me delete this page. Yeah, so my points are minus 3 comma minus 3, 1 comma minus 3, minus 3 comma 1, and 1 comma 1, right? And so for this point, what is FAA?
Minus
This
4.
is minus 4. This point, this is 1, right? 4.
4.
This point, minus 4, right? And for this point, 4. Correct.
Yes.
So for, as you can see, for these conditions, yeah, for maxima, this fxx should be less than 0, first of all. So only 2 cases are there where this is less than 0. So this point and this point. So we only need to focus on these two. Okay. Now for these two, we can calculate the Hessian. So FA we have already got. What is FBB for this point?
4.
This is plus 6, 4. And this one, Minus 4.
-4.
So for -3 comma -3, the Hessian is basically -4 0 0 4. And for -3 comma 1, the Hessian is basically -4 0 0 -4. So the determinant is here -16, here +16. Which one we need? Determinant should be greater than 0, right?
Then
So determinant greater than 0, that means this is the point. So -3 comma 1 is the point, right? Now you can go back to the equation of FAB and put the values of A and B. That will give you the maximum value. That is your M, and then 3M is need to be calculated. That then you can get this value, right? So that is the solution problem. Okay.
so 3m. Okay, okay. It's the value
M
of
will
M.
be, I think, 32/3. That's why 3M we asked for integer. Okay. Yeah. Now for this thing. So 3 points are given, V1, V2 and V3, critical points suppose. And for V1, H1 is the Hessian matrix, for V2, H2 is the Hessian matrix, and V3, H3 is the Hessian matrix. Now, checking this condition, which of the following are true? Now for H1, what is the determinant? 2.
4, 6, 5, sorry.
No, for H1, the determinant is
2.
2. Right. So let me see, and fxx is basically 1. Right. So it is positive. So is it a saddle point?
No, sir.
No. Right? Because if we go back to the conditions, yeah. So determinant is greater than 0. So it cannot be a saddle point. For saddle point, determinant must be less than 0. So first option is not correct, as we can see. Okay. What about the second one? H2. The determinant is
-1.
less than 0.
Yes.
So determinant less than 0, that means it is a saddle point, so it is correct. What about the third point?
6. Determinant is greater than 0, and
Determinant
first
greater than 0.
is greater than 3. So
It's
it's
correct.
So it's a correct, it's local extrema. And do you also point out, is it minima or maxima?
Minima.
It's minima, because fxs is greater than 3. Great. What about the last one?
It's also correct.
It's also correct, because determinant is 4, determinant is greater than 0, and fxx is 2, which is greater than 0. So again, it's a local minima, right? Yeah. So this type of problems are basically here. And now for more than 2 variable, we need to find 3 equation fx, fy, and fz and equate it to 0. Then for minima, again fxx should be greater than 0. And other than the Hessian, we need to find the 2 cross 2 minor, first 2 cross 2 minor also in this case. So if we write the matrix in 3 cross 3, how the matrix will look like? This is so this is the Hessian matrix, right? So determinant of the Hessian matrix, we know that we need to be greater than 0 or less than 0 for the conclusion. And here is another point, which is fxx, fyi minus fx square. So that is basically this portion, this minor, right? The remainder of this minor. So this is fxx, fyy minus fxy fyx, and now these two are equal because all the partial derivatives are continuous. So this is square. So this also we need to find out. Okay, so the condition depends on this portion also. Okay. So let's check for one function. So we have started with this function x cube plus xz square minus 3x square plus y square plus z square. So first of all, check that whether 0, 0, 0 is a critical point or not. That is the first thing we have to check, right? So can you tell me the function so that I can write it here?
X cubed plus xz squared minus 3x squared plus y squared plus 2z squared.
Okay. So first of all, we need to find fx, y, z. So this is 3x square plus z square minus 6x. Fy is basically 2y, and fz 2xz
2x
plus
4z.
4z. So if we equate all these to 0, so from here, from the second one, it is clear y equal to 0 is the solution. And for these two, let's see what are the solution. So here, if we take z common, 2z common, x plus 2 is 0. So either z equal to 0 or x equal to minus 2. Now when z equal to 0, then x equal to x is also 0, right, from the first equation. So 0, 0, 0 is a critical point. There may be some other solution, but it is a critical point. So all the options involve only 0, 0, 0. So it is enough to check that 0, 0, 0 indeed a critical point. And what is fxx? It is 6x minus 6. Fxy is 0. And fxz is 2z. Fyx is 0. Fyy is 2. Fyz is 0. And fzx is 2z. Fzy is 0. Fzz is 2x plus 4. Okay. So if we want to write a Hessian at 0, 0, it is minus 6, 0, 0. Now yx 0, 2, 0. Z, this is 0, 0, 4. Right? This is the Hessian matrix. HF 0, 0, 0. Okay. Now what is the determinant of this matrix? This is the diagonal matrix. So just product of the diagonals. Determinant of HF 0, 0, 0. That is minus 48. Right? So less than 0. So what happened if determinant is less than 0?
Saddle.
As we have seen. Non-zero. So determinant non-zero we can get. At least that we can get, and case 1 and case 2 do not occur. So we have to check these two cases also, right? Whether those are satisfied or not. So basically this portion. So fxx fyy minus fxy square. So this is minus 12, right? So this is also less than 0. So these first two cases are not satisfied, but Hessian matrix is non-zero. That means it is a saddle point. Is that clear? Is it okay? I mean, how to approach this, right? It is basically just calculation, nothing fancy is there. So this is what is the last thing which I intend to discuss today. That is differentiability of a scalar value multivariable function. So do you remember how we have checked differentiability for a single variable function? Do you remember that?
So limit I comes to 0 at no,
So
sir,
can we tell
fully
me?
not remember.
Okay.
A plus and A minus required to be equal.
But where? Suppose at this point I need to calculate x equal to a. Right. So what we have done here? We have taken a plus h, right?
A minus h.
Or a minus h on both sides, basically. And then calculated the slope. So basically, it is for plus 1 plus h0 plus or
0 minus.
0 minus. If both are equal, basically this limit exists.
And it is equal to function value.
No, that's for continuity. That is different. If this limit exists, then we call f is differentiable at a, and this is equal to the derivative at that point. Okay? Fine. So this was the concept of derivative. Now, do you remember what was the equation of tangent in this case?
F FA minus F dash.
This equal to f dash a x minus a, right?
Yes.
So this is what we have done. So if we want to write it, y equal to something. So f dash a x minus a plus f a. And when we are talking about linear approximation of the function at x equal to a, so we are doing the same thing. Linear approximation of the function at x equal to a. So like this we have written. So this is the linear approximation basically. Correct?
Yes, yes.
So instead of this, we just
This is of the form y equal to mx plus c.
exactly y equal to mx plus c. Exactly. So this is what we have got there, right? Now, if you can see little bit in detail, this is your f dash a, correct? Linear approximation minus function value at that point by x minus a, basically the slope, right? So if you can see x minus a as your h, then your x is a plus h. So linear approximation of the function a plus h minus f of a by h. This is your f dash a. Now if h tends to 0, that was the definition, right? Like this. Got that? I mean, can you see the analogy here?
Yes.
Yes. So basically f of a plus h, if you shift, if you are dealing with some point x equal to a, if you take the shift h, then this is the shift in the slope you are dealing with. Now if you try to calculate the linear approximation at that point at a plus h and divide it with the slope, that will be your f dash a. And from there, basically, I mean, how perfect the linear approximation is as we tend to h towards 0, that is your derivative at that point. Now, if you see, remember for multivariable function, Do you remember what is your linear approximation at a comma b? For some point a comma b. Now we are two variable function, right? A comma. So at point a comma b, we are doing this. This is your point.
Sir, this is f of a comma b plus dot product of the gradient and with the unit vector.
Yes, so like this. Correct?
Yes, sir.
A
Sir,
comma
A
b,
minus A comma B. Y minus
y
B.
minus. So this is the linear approximation, right? Basically the equation of tangent, you can say. Correct? Now, if I take this to the other side, so this is fx this plus fy ab y minus b. Now again, like earlier, so here are two increments along x. This is h1. Along y, this is h2. Okay. So x equal to a plus h1. Y is b plus h2. We can do it like this. So L a plus, so not L. So LAB B remain as it is. So what we are getting is LAB minus FAB equal to, this is fx AB h1 plus h2 fy ab. That means h1 h2, if we take it as a vector, dot with gradient of f at a comma b. Correct? That's what we can write.
Yes.
Now if we want to define the, derivative of the function or the differentiability of the function at point, so what we need? We need a plus h1, b plus h1, h2 minus f of ab minus, so this approximation should be as close possible to the function at that point. That is what approximation is. So this is h1 h2, that gradient f of ab by this norm of h. Basically norm of h means root over h1 square plus h2 square, right? So this is what we need. This is what is the point. So if we go back, a plus h means our x, this is y, this is the point we are dealing with. So h1 h2 dot this gradient ab. Now what is this one? This one is basically the distance, the shift, so you can visualize it clearly. Now this xy should approach to AB, which means here this h should approach to 0, 0. Got it? Yeah. So that is what is the definition of differentiability here. A plus h minus fa. So h is a vector, so what I have written as h1 comma h2, that is basically the same thing. And then you have to take the norm to be 0. The distance of the new point from the point a comma b, that point should be minimized so that the linear approximation makes less error. Linear approximation give less error. If that happens, then we call that f is differentiable at that point. Okay, clear? So can you see the analogy here? What with the single variable to the multivariable? The same thing we are doing, but here we are dealing with more than one coordinate. That's what it is. Clear?
Yes, sir, clear. Sir, I want to ask a question. From this, we can derive that the function is differentiable. If the function is differentiable, then it is continuous. And if it is continuous, then the limit also exists. So can we to check whether the function is continuous or not?
Can you?
use this thing to check whether the function is continuous at a point or not?
Yeah, you can check it. But I mean, checking continuity is much easier than checking this condition, no? Because continuity comes before differentiability. But you can use this. That is also okay. You can use it. But sometimes it will be easier to check continuity directly other than using this.
Yes, sir, because the gradient only exists if the function is continuous, and only it is valid.
But you have to check continuity, no? So,
Yeah.
I mean, that's my point. Is so sometimes it is easier to check continuity directly without using this gradient and all this thing.
Actually, sir, I wanted to ask that all these things like the Hessian matrix on the derivatives and this differentiability, they are only possible if the function is continuous at that point.
Not only the function, all the partial derivatives needs to be continuous.
Yes, along with the partial derivatives also.
Yeah, correct. So along each direction of x, y, z, all the partial derivatives should be continuous. Otherwise, it will be difficult. Okay.
Yeah, right. Sir, practice assignment solutions have not been uploaded.
Okay, I will upload that.
Sir, in this last line, second last line, how did we come to, where did we get this minus FAB minus H1 H2's dot product with the gradient? I mean, what have we equated it to? The value of the function at AB?
No. So see, this is what is L A comma B, linear approximation at the point A comma B. That is f of AB plus H1 H2 dot gradient of f of AB, right? This portion.
Yes.
So, and now I am shifting to some point by this H1 and H2. And this portion is basically a linear approximation. This portion.
At point AB,
now
right?
At point AB.
At point AB.
Yeah. So what it is saying, so yeah, you asked the valid question, very nice question. So this is what the functional value, if we shift from AB to A plus H1 to B plus H1, right? And we have a linear approximation at that point L of AB. Right? Okay. If we make this change very small, this H1 and H2, this change very small, then this shift, I mean the change in functional value, this approximation, the error should be minimized, right? When we take this very small, right? It should be. Then we will get a perfect linear approximation, right? So it will only be possible if this function is differentiable. That's why we get this. Now if you put back the value of LAB, so this is your LAB, this one, right? That's what we got. Okay. So you are basically not this. This norm should be going to 0. This portion should go into 0, not individually.
Okay.
Okay. The distance. Okay. Fine. So
at the point AB. At the point AB.
Yeah, right. Basically, this AB is going towards A plus H1, comma B plus H2. What does this mean? Here is your point A, comma B. Here is some point A plus H1, B plus H2. Right? This distance should be minimized. Right? This point should come closer to this point. That means what? What is the distance between these 2 points? This.
Yeah. The norm.
This. Square root of this.
Okay.
So A cancel, B cancel out. So this is basically H1 square plus H2 square. Right? And this should be tending to 0. That means the norm of H should tends to 0. And the linear approximation should come closer to this value of the function. Because that's what linear approximation is supposed to do. Right? I mean, we have to approximate the function. Now, what is linear approximation? Linear approximation is basically L of AB is basically f of A comma B plus this H1 H2 dot gradient
Dot.
of this is linear approximation. That's why we came to this definition. Got it?
Yeah, I got it, but it's really tough to remember.
I mean, it is difficult to visualize, that's true. But if you can find the analogy between, that's why draw this analogy with single variable first. Here
Yeah,
also we are
that
doing the
made
same
it
thing.
clearer. Yeah, it made it a
Ah,
little easier to understand.
yeah. So basically we want to make our linear approximation as nice as possible. Yeah, and we can do this only when the function is differentiable at that point. That is the idea behind all this. Okay. Yeah, so this is what we need to discuss, and some problems are there. So you can check whether these functions are differentiable or not at 0, comma 0 using this definition, right? So if we take, suppose, which one should we do?
Sir, anyone can be solved. It is quite clear.
Huh. So suppose we take this one, last one, e power x square plus y square, okay?
Yes.
Whether it is differentiable at 0, comma 0. So let's see how to do it. So the function is e power x square plus y square. At 0, comma 0, we need to check differentiability. Okay. So what we have to do? So 0 plus h1, 0 plus h2 minus f of 0, comma 0 minus h1, h2 gradient of f at 0, comma 0. Right? This is dot product and this is norm of h. Correct? This is what we need. So what is this limit? If limit is 0, then we know that this function is differentiable. That means the linear approximation is nicer. So this is f of h1, h2. What is f of 0, comma 0? This is 1, right? And what is gradient of f at? So this is x square plus y square 2x. And fy, x square plus y square. At 0, comma 0, both are 0, right? This is no. So what I got here, this is 1, this is norm h. Till this one it is clear to everyone. Now this is e power h1 square to h2 square minus 1 by this is root of h1 square plus h2 square, and this is h1 square plus h2 square tending to 0. Right? Do you know this limit?
Yes, sir.
What is it?
1.
So, 1. So, this we can call it,
So
suppose m.
e to the power x upon x is equal to 1 h upon h.
So m tending to 0, e power m minus 1 by m. Right? This is what we got. Right? Correct?
Is equal to 1.
Sir, what did we root m?
This one.
Yeah, if this is m, then
M square, m square. So this is m square I have written. So this is, should we write m square? M. So
Yeah,
this should be under root, right? No, I am doing something wrong here. This should be m squared, sorry. This is m. Now what is this limit, basically? Right? This is clear, right? h square, h1 square plus h2 square, I am writing at m square. So square root of this is basically m, some positive number. Because we are dealing with now, so everything is positive here, right? So, and it is tending to 0. So it is, the given function is e power m square minus 1 by m, correct? Where m tends to 0. Now what is this limit? Do you know that? Do you know this limit? Do you remember L'Hopital's rule?
Will it be m?
But can you use L'Hopital's rule to conclude the limit? So above this is 1 minus 1, so it is 0, and this is 0. So this is in 0 by 0 form, right? Correct? So we can differentiate it. So 2m and by 1. Correct? Now can we put the limit? What do we get? Is it clear?
Yes.
Is it clear to everyone? Anyone has a doubt here in this question? Okay. So this is how we have to check the differentiability of a function. So let's see another problem if we can do. Yeah. Which one? So suppose third one. Let's do the third one. fxy. Okay, so let's do all the options first. So fxy x plus y, is it differentiable at 0, 0?
Yes, it is different.
It is differentiable. Why?
Because it's like a polynomial.
Exactly. So any polynomial type of function will be differentiable, and if you want to check using this definition also, then also you can get till there. So let's see what happens. fxy is x plus y. So limit norm of h tending to 0. So at 0, 0 we are checking 0, 0. Yeah. So this is h1 h2 minus f of 0, 0, and gradient mean fx is 1, fy is also 1, right? So h1 h2 dot 1 comma 1 norm of h. So limit norm of h tending to 0 is h1 plus h2 minus, this is 0 and this is, if you take the dot product, h1 plus h2 norm of h. So the numerator is becoming 0. So the limit will be 0 anyway. So this function is differentiable. It is easy to check. Correct? Any doubt at this point? Now what about the second one? Is it differentiable? xy by x square plus y square? Is it differentiable?
I think no, sir.
Why?
No, because this function is not continuous.
Exactly. So it is not continuous at 0, 0, right? Yeah. Because limit does not exist.
Yeah.
Right? Limit at 0 does not exist for this function. So it is not continuous at that point.
So in this type of question, we cannot do further calculation. It's looking like it's not continuous. So it's not differentiable.
Not looking like, I mean, you can conclude why we take y equal to mx. Right? So for defined time, you will get defined value for the limit. So the limit does not exist, so it is not continuous. So it is not continuous means it cannot be differentiable, because if it is differentiable then it must be continuous. So if it is not continuous, then no point of checking differentiability. Correct? Got it?
Again, sir.
So let me write this function. So this is the function it is given, not 0, 0 at 0. I think this is the function. Okay. So my point is, first question is fxy limit xy tending to 0, 0 exist. This is the question. Does this limit exist? How can we check that? This is the famous example, y equal to, so take y equal to mx. If we approach to the origin by this line y equal to mx, what we get? We get x
mx
x square
m square x.
So basically m by 1 plus m square. So for defined value of m, you will get different limit, right? When you are approaching to 0, 0. So if you take y equal to x line, you will get half, right? You will get y equal to 2x line and approach towards origin, then what you will get? 2 by 5. So different, for different m, you will get different limits. But if limit exists, then all this should be same, right? Because limit is unique. So here we can conclude limit does not exist. Exists at origin. The limit does not exist means this function is not continuous. So fxy is not continuous at 0, 0. Correct? So we can conclude that fxy is not differentiable. Because differentiability implies continuity. I mean, if a function is a differentiable, then it must be continuous. Now, this is not continuous, so it cannot be differentiable. Correct? Got it?
Yes.
Okay, fine. What about the next one? This one? Third one?
So it is not.
Why?
Because same, sir.
So you're saying it is not continuous?
Yes.
It is not differentiable.
It is not differentiable, I am coming later, but is it continuous? Is this function continuous or not continuous?
I don't think it has a limit.
Then prove it. It does not have a limit. That limit does not exist, then you have to prove it, right? How can I prove it? The same approach will work.
Yes, above.
Really? The same approach will work? So let's see. So the function is?
But y is equal to mx, m will come. So like,
let's see. If consider if this is the function. Now you are saying again take y equal to mx, right? So if you put y equal to mx, what you will get? This, right? So here it is mx square, here x come up.
Has a limit.
So this does not conclude anything, right? If we take y equal to mx, still we are getting limit to be 0. For defined time, we will not get defined values or limit because here x is there, right? So the same approach will not work. Now, can we find any other curve so that this limit is so that you can show that limit does not exist, or is limit actually exist here? I mean, this function is actually continuous. Can that happen? What do you think?
What if we take minus y is equal to minus mx?
I mean, plus m and
Y
minus
is
f
equal
does
to
not
mx square.
Minus
anything
x.
different, right?
Mx square, sir.
Mx square. Okay, put it. So it is mx cube. M square x power 4. So this is mx cube. Then x square, so x will come out. So again x will be there, no? So again it will be
What if
0.
we take root x?
Okay. You put yourself and see what happens. Root x. Y equal to root x, you are saying, right?
Yeah, can we do that? I don't even know if we can do that.
Yeah, I mean, it's a curve. You can put any curve which passing through 0. So y equal to root x, you are saying, right? So what does it mean? This is x power 3 by 2. This is x. I mean, so if you take any m here outside, so it is m, m square. Again, x will be there, as you can see, right? If you root x will be cancelled out, and some x will be there.
Yes.
Yeah. So have not you come across this problem in week 10? Anywhere? In your assignment or activity question?
We must have, I think.
Yeah. Okay. Is this statement true? Is this statement true?
Yes, sir. If y is equal to 0, then
No, in general, for any xy.
Yes, because y squared will be positive.
Yeah, correct. So basically, if we square it, then what we get? We get this one. Right? And this is always true, right? Because if we take x square in this side, so 0 is less than equal to y square. So y square is always greater than 0, that we know. So from here, we can conclude till here, right? It's okay, right?
Yes.
Yeah, sir. Yeah.
Yeah. Now, similarly, this is also true, right?
Yes.
Same thing, so by symmetry. So this is less than equal to x square plus y square, correct? Just product, take the product. Both of them are positive. So by taking the product, we can conclude it, right?
Yes.
Okay. Okay. Now, can we write this? Correct? We can write it, right? If mod of some number is less than some number, then it is less than plus and minus in between that. Correct?
Yeah, sir. Yeah.
I mean, is it clear to everyone? I mean, if mod of A is less than 3, what does it mean? A should lie in plus 3 and minus 3, right?
yes.
Then only mod will be less than 3. Otherwise, mod will be greater than 3, right? So it should be the same thing I have done here. Okay. Now, if we divide it with x square plus y square, I mean root of x square plus y square. Okay. So what we got here? The middle one is our function, right? And this is minus root x square plus y square. This is our fxy when xy not equal to 0. And this is, right? Now if we take limit xy tending to 0, 0, basically I am applying sandwich theorem. What is the limit?
0.
Is it clear? So this one is also going to 0, this one is also going to 0, so it is in between. So limit of our function exists and it is indeed 0, 0. Correct?
Yes.
Okay. So in this case, limit exists and the limit is 0, and which is same as f of 0, 0, right? Because that's what the definition says. At 0, 0, this is 0. So the function is indeed continuous. This function is continuous. Okay. Now we have to check for differentiability. So by showing that this is not continuous, so it is not differentiable, that argument is not working here because the function is continuous. So what is in our hand? In our hand there is differentiability. We have to check differentiability using the definition, right? So this is h1, h2, this minus. Now grad we have to again calculate at 0, 0, and no. So can you do it? What is fx? Fx 0, 0 and fy 0, 0. So we have to use definition because at 0 there is some I mean piecewise defined function. This is so what is this one? First one f h, 0. So this is our function. So h, 0 means this is 0, right?
Yes.
Minus 0, so denominator is 0. So all these are 0 basically. Okay, so these two we know that is 0. So what about the limit of this? This is h1, h2 root over h1 square plus h2 square. This is 0 and this is also 0 by norm of h. Norm of h means h1 square plus h2 square. Okay, so what we get? h1 h2 by h1 square plus h2 square, right? This is what we got. Now, do you know what this limit is? Do you know what this limit is?
0.
Is it? This is like limit xy by x square plus y square, no? Like this, no? So
0.
we have already checked earlier that this limit does not exist. So this limit will not exist, right? Because we approach the norm to 0, the norm is approaching towards 0. Now if we take this straight line, h2 equal to mh1, and our norm is approaching via this straight line to 0, then for different value of m we will get different limit. So this limit does not exist. Clear? So this is one important example where the function is continuous, but it is not differentiable. Clear? So I think this is one problem in your practice assignment. Okay? Any doubt?
Sir,
Anyone has any doubt on this?
hello, sir.
Yeah.
Sir, in partial differentiation, H is a unit vector, like, or we can say H is a directional vector. But by the definition
H is
of
not a directional
differential,
vector. I mean, H is not a unit vector.
the zero H along X has
H is
partial
the
difference.
increment. H is the increment along the vector 1 comma 0 or 0 comma 1, depending on which you are taking.
For differentiability definition, sir, H is an increment vector. But in
Always
partial,
H is not vector. I mean, H is the increment basically.
oh, just an increment. Okay, sir.
So for differentiable, we are taking with h1 comma h2. So we are
Yeah.
taking it as a vector.
Okay.
And here, what we are doing for partial differential.
Yeah.
So this is basically f of ab
Plus
h into
A.
1 comma 0, like
Yeah.
this.
Yeah.
Okay, increment along the direction 1 comma 0. This is the
Okay.
unit
Okay.
vector.
Okay.
For when you are taking with respect to y, it will be 0 comma 1. Correct?
Okay.
Same thing.
Increment along y-axis.
Exactly, increment along x-axis or y-axis or any other axis for other multivariate.
Okay.
Okay. Yeah. Okay. So any doubt till this? I mean, for this question. So at the end we get to some limit which does not exist. So I mean, for differentiation, I mean, for the function to be differentiable, this limit should be 0. But here we can see that this limit does not exist. So we can conclude that the function is not differentiable, though it is continuous. Okay. So fxy is not differentiable. It's okay. Is it clear? Anyone has any doubt?
Sir, in the question prior to this one, there was one option with mod x, or I don't know, mod xy. Could you just repeat that?
Now you can solve it. No, I have solved this question. Now it will be easier for you to solve this one. Same approach. Same approach.
That's sandwich theorem.
Exactly, Sandwich theorem. So, I mean, to prove continuity, you have to use Sandwich theorem, but for differentiability, you can use the same thing what I have done here. Right? We have not asked continuity here, right? So for the next question also, I mean, this one also we have not asked continuity, but you guess that it may be continuous. That's why I have shown that it is actually a continuous function, but still it is not differentiable. So if you only have to check differentiability, you can start from here itself, this point. Okay, the definition of differentiability. Then you can move forward. The same type of thing will come. Okay.
But how will we find the gradient with that mod phi?
Same thing. Okay, so let's see. But it is way better that if you can do it. So x mod
Actually, I
y.
did something similar, I think, in activity question 11.1, question 6, and I couldn't do it.
Okay. So x mod y. This one, right? And 0. Okay. So we need fx at 0 comma 0. What is that? You take the h comma 0 minus f of 0 by definition. So what is h comma 0? What is h comma 0?
0,
H comma 0? 0.
0.
So it is 0 indeed. And what about this?
Zero again.
Again 0, right? So really this does not matter. I mean, finding this is not really difficult here. So norm of h is going to 0. So f of h1 h2 minus f of 0 comma 0 minus h1 dot gradient at 0 by norm of h. So what we got here? So this is 0, right?
Yes.
This is also 0. This is
Yes.
only f of h1 h2. So h1 mod h2 by h1 square h2 square, right? By norm of h means this, correct?
Yes.
So there is a square root of this. Yeah. So what if we write this? This is norm h tending to 0, h1 mod h2 by h1 square plus h2 square. Now I left whether this limit exists or not.
That one we just proved something similar of xy upon x
Exactly.
squared plus y
Exactly.
squared.
Yeah. Yeah.
So if that did not exist, most likely this does not exist.
This does not exist. This limit does not exist. Correct.
Okay, so it's not differentiable.
It's not differentiable. Exactly. Got it? I
Yeah.
mean, it is not
But
really
these
hard
questions
once
are
you
very
are.
lengthy. Very, very lengthy.
No, this is not lengthy. I mean, you really don't have to calculate anything, as you can see. I am explaining, that's why it is taking more time, but once you do it on your own, you can do it really quick.
But we have to do this for 4 options, 4 different options. It's like 4 different questions.
That's true. But in exam, we will take care of that. We will not give so many questions so that you cannot finish in
But
time.
in this type of question, first we find the continuity, then we differentiate.
Your voice is breaking, but still, if I get the point right,
Hello.
no, when I am asking about whether a function is differentiable or not, you only have to check differentiability. You don't have to focus on continuity. But sometimes you may have to focus on continuity because, like this option 2, you know that this function is not continuous. This is quite easier to check that this function is not continuous. Right? So once it is not continuous, then you can directly conclude that this is not differentiable. But if a function is
Yes.
not differentiable or it is continuous, that doesn't matter actually. So you can check directly differentiability in that case, right?
But some question we cannot know that is this is xy upon x square plus y square. It is not a continuous. But in
So
this
this you
as
know, right? This is not a
we
continuous function.
Hmm.
So if you know this is not a continuous function, my point is you can directly conclude it that it is not differentiable. You don't have to check it further. But if you don't know whether, suppose the option 3, third option. So if you don't know whether this function is
Yes.
continuous or not, suppose you don't know, now you know it is continuous. Suppose you don't know, you don't have to check the continuity. You go directly to differentiability and check whether it is differentiable or not. Because this question asks for differentiability. You don't have to move around continuity here.
Then we find the continuous at none.
No, I mean, if we ask that it is continuous or not, because you can see this third option, for this third option, this function is not differentiable, but it is continuous. Now, if we ask that whether this function is continuous or not, you have to check for continuity. But here we ask it is differentiable or not. So it is enough that you can check the differentiability of this function and find out that it is not differentiable. That is okay. Got it? Is it okay? Bhavna, your voice is really breaking. So can you put it in chat? I mean, I am not.
Yes.
Yeah, just put it in chat. I am not really getting your voice. I don't know. I mean, for others. Can you just put it in chat? What you are asking?
Sir, we have a Python PPE this Sunday, and our 11th week graded assignment submission is also on Sunday. So,
Okay.
and as we've always had that our portal does not work the whole day on that
So
day,
you have to submit it before Sunday, probably in this.
so the deadline will not get extended.
No, no. Now there is no point of getting extended.
Okay.
You can ask to the support team, but probably it will not get extended.
Sir, would you be giving the mock test tomorrow?
Yeah, not tomorrow. So there is a mock on week 9 and week 10. That is on 25th, this Monday, 25th and 26th. 2 days it will be open. You can try on your own. So this will be mock on week 9 and 10. And next week, 1st and 2nd August, there will be mock on enter. Okay, there will be mock paper on enter. So on these 2 days, you can try on your own. There will be 4 revision session, 26th, 29th, 2nd, and 5th. 4 revision session will be there. Okay.
Sir, there is no week 12 or week 12 graded
No, there is
assignment.
no week 12 in, no, nothing is in week 12. Okay. So whatever we have studied till now, that is your syllabus, and that's what we have in Maths 2. Okay. So only the revision sessions are remaining. So next week I will take some revision sessions. Okay.
Sir, I want to make one request. Please upload the solutions of the practice assignment.
Week 11 practice, is it?
Yeah, yes.
Yes.
Yeah, I will upload it. I will upload it right now. Yeah.
Sir, I'm audible.
Yeah, now you are audible.
Sir, I'm asking if you're asking the in question it is continuous or not, then we find it is then we solve that one.
Exactly. Then you solve for continuity. So whether limit exists or if limit exists, that is same as the functional value. That is the definition of continuity, right? So in that case, you solve for continuity. Now, if we ask for differentiability, sometimes it is easier to know whether the function is continuous or not, because if you know the function is not continuous, like we have seen in option 2, then you can directly conclude that it is not differentiable, because differentiability implies continuity. So if it is not continuous, then there is no point in checking for differentiability. But
so
even if you don't know,
yes,
even if you don't know the function is continuous or not, like in option 3, you don't know whether this function is continuous or not, and the question is asking for differentiability, you check directly for differentiability. No need to check for continuity. Okay.
Clear.
Sir, can you share please some statistics about these two, sir? These two results.
That I can share. So, okay, so let me close this now. Yeah. Quiz 2 result, no? Okay. Let's see where it is. 1 minute, I am stop sharing, then I will. Yeah, so this is your quiz 2 data. Okay. So I think the number of attendees of the exam is very less, because more than 1,000 have not attended quiz 2. Probably they have already got their marks in quiz 1. That's why they have not attended quiz 2. And yeah, the marks are really low, that you can see. I mean, average score is out of 100, it is 36 average score. And the pass percentage is also really low.
Okay. And this last line is number of candidates with final score between 36 to 39 out of 100.
Yeah, out of 100. So these 162 participants have got their marks between 36 and 39. So 40 is the pass mark, right? So we also keep track who are at the border line. So these 162 are in between 36 and 39. And this is the average mark, 36.86. That is out of 100.
Sir, will Anthem be this difficult also?
Was quiz too difficult?
No,
No,
sir, not.
so much.
Much, right?
Not really.
So
But I did some little mistake in calculation.
yeah, right. May I know how much marks that you got?
Sir, 58.
Okay. Right. Divya, how much marks you got?
92.
Oh, great. Then you are saying this is difficult.
But sir, week 9 onwards, it's so tough. I don't remember anything.
No, actually, if you see week 9, 10, and 11 are easy because there is nothing much to do.
And in last term, there was a girl named Sandhya. She used to score
Yeah.
about 90.
Okay.
And quizzes.
No, I mean, that's good. That's good. I mean, there must be some students who can do good marks. That's okay. I mean, if you see week 9, 10, and 11, that are quite easy. I mean, if you compare it to week 6 and 7.
So actually, the questions which are more theory based, which check our conceptual, knowledge, those ones are the ones that are very tough.
Yeah, so basically, the question which will come from week 9, 10, and 11 will be conceptual. So today I was doing some calculation, and you have seen I have also done some calculation mistake. So that can happen to everyone. But in exam, we will ask the question which will test your concept, not your
That is
calculation.
the one which is the toughest. The one which tests our concepts. Those are the ones which are hard to prove, whether it's differentiable, whether the limit exists or
But
not.
the concepts of week 9, 10, and 11 are easy, right? Not very tough.
There's so many
As a concept,
concepts.
they are easy.
Very many concepts. Very many.
Yeah,
That's true.
that's true. That's true. Yeah, but don't fear about the NSEM exam. It will be easier. I mean, you can do well. Yeah.
Yes, sir. So level will be of quiz 2 only, right?
Mm, yeah, more or less near quiz 2, or maybe little bit
Easy.
more conceptual question will be there
Okay.
because this is your end term. So the question should be little bit more conceptual. But don't worry, the question, I mean, attempt the mock test or the mock of week 9 and 10 and the mock of enter. Attend that question, that paper, and
Sir, when will
understand the
the
solution properly.
Yes, sir. Yes, sir.
sir, when will be the
Yes,
mock
ma'am.
of 9 and 10?
Mock of 9 and 10 is on 25th and 26th. I mean, this upcoming Monday and Tuesday. And 1st and 2nd August will be mock of enter. So you can attempt at your own time, but I will suggest that fix a time limit for yourself. I mean, suppose take 2 hours and solve the entire mock in those 2 hours. Take 1 hour for week 9, 10 mock. So
Sir,
you can
half hour.
timing among yourself. Yeah.
Sir, but we will not get 2 hour in our main exam, I think.
Then 1.5 hour, right?
1.5 hour. Yeah.
Do it. Then take 1.5 hour and solve it. Okay. I mean, question will be like that.
Okay,
You
sir.
can solve it within 1.5 hour.
Similar
It will
question.
be a 50 mark question. I mean, 15, 16 question will be there probably. So, and try to, I mean, visualize the concept which are related with each other. I mean, suppose you take a concept for week 7, we can relate it to a concept of week 4 also.
Yes, sir.
There is a connection. And I always try to, when I have taken life session, I always try to point out where the connections are. Right?
Yeah.
So that is really important because there may be one question which needs 2 or 3 concepts from different week.
Yes, sir.
Right? So try to focus on that. That will be really helpful when you go ahead with the degree course or more, upcoming courses, MLF.
Sir, 4 to 7 are really related with each other. What I found.
Basically, all the concepts, even week 9, 10, 11 are also related to week
Yes.
7 and 8. Because, see, the tangent plane, what are tangent planes? They are affine surfaces, right?
Yeah, kind of. Yeah.
So, if I give you a function and ask you what is the dimension, find a basis for the tangent plane. Find a basis for the subspace corresponding to the tangent plane. So that is a question which really connects all the concept. Right?
Yes, sir. Yes, sir.
You have to know how to find the tangent plane. You have to know how to visualize it as an affine subspace. Then have to know what is the corresponding vector subspace, and you have to know how to find the basis of the vector subspace. Right?
Yes,
So
sir.
all the concepts are weaved together in a single question. So this type of question will come in exam.
Sir, but we don't have any practice of this type of question, I think.
No, that's why I am asking you to attempt these mock tests.
Okay, sir. Yeah. In the mock we will.
And in revision session we will discuss.
Okay, sure. Yeah.
In revision session we will discuss definitely. So I have not taken any live session for week 6 and 7, I think, or 7 and 8.
Yes, sir. You have taken.
So in revision session I will discuss those concepts also once.
Okay, sir. Sure.
Yeah.
Thank you so much, sir.
Yeah. Okay. Okay. So
Thanks, sir.
any other thing you want to say? Anyone? Or we can close the session then. So
Sir,
I will upload the practice assignment solution.
Sir, one
I will
more
upload
doubt. Will we have some
Yeah.
question on the figures? Like figure will be given and then we have to identify the which order of differential function or plane is this, like that.
No, that is not. By seeing a figure, you cannot identify the function always. So that is not a good
Plane.
kind of question. That will not be there.
Okay, sir.
Yeah.
Thanks.
Yeah. Okay, fine. See you later next. Yeah.
Bye,
Sir,
sir.
for finding,
Thank you, sir.
Yeah, Santosh, go ahead.
Yeah, sir. Sir, for finding maximum or minimum surface area of a rectangular box, we can apply Hessian test, sir.
Yeah. Basically, when you are maximizing some surface area or volume, you are dealing with a multivariable function, right? Functions of length, breadth, and width. So it is a multivariable function. If you take it x, y, z, so your surface area will be xy plus yz plus zx. Right? Then you are maximizing this function. You have to find the critical point of this function, and some condition may be given on x, y, z. So using that, you do the same thing. Now treat it as a function, multivariable function, and calculate the Hessian matrix to find maximum or minimum, all these things. Okay?
Yes, sir.
Okay, fine.
Bye.
Okay, then see you later next week.
Sir. So will you take all the revision session?
Not all the revisions, I will take some.
Don't take first session and take other 3.
Don't
Because
take
I think in
fast.
the first one we will discuss 1 to 4, which is very easy.
Okay, let's see.
Okay, sir. Thank you so much.
Yeah. Okay.
Thank you, sir. Good night.
Yeah, welcome.